You see, the laws of science describe how the universe behaves, but to understand the universe at the deepest level, we also need to understand why. Why is there something rather than nothing? Why do we exist? Why this particular set of laws, and not some other? I believe the answer to all these questions is M-theory. M-theory is the only unified theory which has all the properties that we think the final theory ought to have. It is not a theory in the usual sense, but it is a whole family of different theories, each of which is a good description of observations only in some range of physical situations. M-theory predicts that a great many universes were created out of nothing. These multiple universes can arise naturally from physical law. Each universe has many possible histories and many possible states at later times, that is, at times like the present, long after their creation. Most of these states will be quite unlike the universe we observe, and quite unsuitable for the existence of any form of life. Only a very few would allow creatures, like us, to exist. Thus our presence selects out from this vast array only those universes that are compatible with our existence. Although we are puny and insignificant on the scale of the cosmos, this makes us in a sense, lords of creation. There is still hope that we see the first evidence for M-theory at the LHC particle accelerator in Geneva. I don't feel the same way about the Higgs boson. Physics would be far more interesting if it had not been found. A few weeks ago, Peter Higgs and Francois Englert shared the Nobel Prize for their work on the boson, and they richly deserved it. Congratulations to them both. But the discovery of the new particle came at a personal cost. I had a bet with Gordon Kane of Michigan University that the Higgs particle wouldn't be found. The Nobel Prize cost me $100. Most recent advances in cosmology have been achieved from space, where there are uninterrupted views of our vast and beautiful universe. But we must also continue to go into space for the future of humanity. I don't think we will survive another 1,000 years without escaping beyond our fragile planet. I therefore want to encourage public interest in space, and I've been getting my training in early. So let me finish by reflecting on the state of the universe. The latest Nobel is another reminder that this is a glorious time to be alive and doing research in theoretical physics. Our picture of the universe has changed a great deal in the last 50 years, and I'm happy if I have made a small contribution. The fact that we humans, who are ourselves mere collections of fundamental particles of nature, have been able to come this close to an understanding of the laws governing us and our universe is a great triumph. I want to share my excitement and enthusiasm about this quest. So remember to look up at the stars and not down at your feet. Try to make sense of what you see and hold on to that childlike wonder about what makes the universe exist. I also hope that the Science Museum's smashing new Collider exhibition will help satisfy our boundless curiosity about our place in the universe. There are many ambitious experiments planned for the future. We will map the positions of billions of galaxies, and with the help of supercomputers like Cosmos, we will better understand our place in the universe. Perhaps one day, we will be able to use gravitational waves to look right back into the heart of the Big Bang. Most recent advances in cosmology have been achieved from space, where there are uninterrupted views of our vast and beautiful universe. But we must also continue to go into space for the future of humanity.